Hello and welcome back to this new series on Python 4DH, in which we have our much more zoomed in and workable code. In this video, we're going to be talking about lists. Now, in the last video, we talked about tuples. And tuples and lists are kind of identical data structures, really. They both contain a list of items. The difference is that lists are mutable, which means they can be changed in memory. Now, this might not sound like a big difference, but it is. It is a huge difference. This little tiny change in lists allows for them to be a lot more useful, and one of the things that you're going to use a lot in Python. So I highly recommend that you spend time and get familiar with lists. Watch this video multiple times and make sure that you understand how lists work and some of the main concepts and functions or methods that are going to be associated with lists. Because if you can command all of these real quickly and just kind of write them as if you're just talking in your native language, you're going to find that you're going to be a much better and much more efficient programmer. So let's jump right in. I'm going to make an object. We're going to call it L for list. And we're going to make that equal to a list. And we're going to make this equal to, for right now, just 1, 2, 3, 4, and 5. Now what this is a list. We can tell that it's a list because it has an open and a close square brackets, with each item being separated by a comma. So 1, comma, 2, comma, 3, etc. And like the tuple, we can have a list that consists of lists. Ooh, helps if I actually do a comma. There we go. But we're going to get rid of that for right now. So this is going to be the main thing that we work with throughout this video, this very simple list, but it's going to allow us to show some pretty complex things that we can do to it. All right, so let's just jump right in. So we've demonstrated how to create a list. What if we wanted to add something to this list for whatever reason? Now, oftentimes you're not going to do this manually. You're going to do this in for loops, but we're not there yet. So right now we're just learning the key concepts. So what you're going to do is you are going to say l.append and open and a close parentheses, and you're going to say what you want to append. So if I want to append a 6, I can do that. Now if I run this, nothing's going to happen. Why is that? Well, I haven't printed anything off, so I haven't been able to really kind of see what's occurring. I'm going to print this off now. And what you're seeing here is something that is different from a string. When we print this off, we're seeing that 6 has been added to our object. If I were to print off before this statement, we're going to see two different lists. And this is an example of what happens to a mutable object in Python. We are seeing that the object is being changed in memory. Here it is only 1, 2, 3, 4, 5, and here it has the 6 appended to it. Now, if we were to do something like this with a string, this would not be the case. Let me demonstrate what I mean. Let's take a string, we're just going to call it s. We're going to say hello, and we're going to make another string, we're going to call it, we're just going to do this, s. I'm going to do s.split, and we're going to split it. My name is Earl. Great show. And we're going to split it with a blank space. So if I were to print this off, print s, and then print s after, we are not going to see anything change. Why is that? Because a string is an immutable object. It can't be changed in memory. In order for us to see this change, think about what you might have to do. Go back to a couple lectures ago. Pause the video and try to figure this one out. How would you change this to make it print off something different? Okay, so if you said create a new variable and print that new variable off, you would be right. So if we go back down, we'll see that my name is Earl is now a new object that is a list and a string. So that's an example of how immutable and mutable objects differ. Okay, let's jump right back to our kind of to-do list over here. we've got l.append, which allows us to add something to L, which is a list. How would we want to clear something? How would we want to take something away? Well, we can, a couple different ways. We can do this l.clear, and you print off L, it's now gone. Another thing you can do is say L equals an empty list. It'll do the same thing. You're essentially just creating a new object that replaces the previous one. Both work just fine. Really, it's kind of more personal preference than anything else. There's another thing you can do. You can delete a specific item in a list. And so you can say delete, we're going to say L, and use the square brackets. And if you remember from our last video, square brackets mean that you are indexing. You are indexing a list. You're going to index a list the same way you index a tuple. And what you're going to do in here is tell Python what you want to delete. And so what you're going to do is insert a number. And this integer is going to correspond to an index in this list. So if I delete position number 0, it's going to delete the 1. Let's print this off, and we see that 1 is gone. We can do this for the same thing. We can do this for 2 as well by printing off or deleting position number 2. So that's how indexing works, and that's how you can delete a specific item in a list. Let's say for whatever reason, we're going to make an L2 right here. I'm going to delete that. And we're going to make this equal to a string of words that are something like, let's say, hello. You know what? I'm just going to do it the lazy way. I'm going to go back to our hello, my name is Earl. I'm going to take a string, hello, my name is Earl, and I'm going to create the object s1, and that's going to be equal to s.split, and we're going to split it by that. So now when we print off s1, just so you can kind of see what's happening in memory, we are going to have hello, my name is Earl, all like this, all as different, split up different words from that. Now, what would I do, or how would I go about kind of reconstituting all of this back into a sentence? Well, I could just print off S instead, but for whatever reason, I don't want to do that, or for whatever reason, all of my words are in a long list. How do I concatenate and bring these all together? Well, I'm going to use what's known as the join operator. And I'm going to do this by simply creating a new object. I'm going to call this S2, and that's going to be equal to, and first thing I'm going to do is say how I want to join this together. So I can join it together with a space, and that's going to bring everything back together the way it was. I'm going to say dot join, and then I'm going to pass in one argument, and that's going to be S1. So now when I print off S2, we have a perfectly reconstituted sentence. And we can change this to whatever we want. We can make it where there's a period in between each word. As you can see down here, it printed that off. We can do whatever we need to. This is going to be very useful when you're working with data in for loops, when you have to bring words that have been separated from a text back together. Believe it or not, you're going to use this a lot more frequently than you might think. So that's how you join items in a list kind of together into one long string is what they're going to be rendered as. But one of the most important things you're going to have to learn how to do with lists, and you're going to do this all the time, is you're going to have to figure out the length of a list. And I'm going to get into why this is important in lecture number 10 and lecture number 9 under for and while loops. The reason why you need to find the length of a list, I'll tell you right now, is because if you try to retrieve something, so if I were to print off L with an index of, I'm going to go 1 too high, 6, what I'm going to do is I'm going to receive an error. It's an index error that says this list is out of range. And the reason is because there isn't a 6th position. In fact, there's not even a 5th position because that's position number 4. So the reason why you need to know the length of a list is so that you can know when to typically stop your for loops if you are going to use the range operator. And again, I'm going to get into that in lecture number 9. So how do you find the length of a list? Well, it's quite easy. All you have to do is simply print off len and in parentheses L, then the item that you want to see the length of. And you can print that off and make sure that you have an open and a closed parentheses for both print and an open and a closed parentheses for what length is being found. So print that off, and we see that our length is 5. 1, 2, 3, 4, 5. It's found that for us. This is very, very useful. I highly recommend you just memorize this one. You're going to be using it in most of your scripts, I promise you. And the length function can also work for strings. Let's go back to, hello, my name is Earl. We can print off the length of S, and you're going to get 21, which is counting all of the characters in there. If you wanted to figure out the length of S with everything kind of split up, you can pass an operator within this. I'm getting a little fancy right now, I know. We can split that up between words, and then you can figure out how many words are in there. What this is basically doing is it's asking Python to print off the list of S after it splits S by a space. It's usually easier when you're first coming into Python to do all this manually in individual lines, but as you get better at it, you're going to start kind of just writing code that looks more and more like this, with functions kind of built on top of a single line. So that's how we figure out the length of a list. There's a couple other fun things that we can do with lists. So let's say I want to print off L, and I want to index, but I don't want to just print off the first position. I want to grab these first two items. Well, I can do that with what's known as a slice. We do that by inserting a colon right here, and we put a start, and we want to end at position 2, which is going to grab the first two positions in that list. And then we print that off, we see that we have 1 and 2 right down here. Position 0, position 1. That's where it's going to stop. It's not going to grab position 2. If we want position 2, we can pass it up and do an index at 3. So we can do that. We can also leave that blank and print off everything in the list, and we can start at positions 1. We can do the exact opposite. We can tell it to print everything off up to position 3. And we can see we can just get that. And we can also tell it that we want to just print off a negative position. What is this going to do? Well, what that's going to do is it's going to print off the last one. And then if we do -2, it's going to print off the last one, 2. It's going to move down and do a reverse index. Now, your reverse index doesn't start at 0. It starts at -1, -2, -3, etc., and goes backwards that way. So that's going to be how you can print off a reverse index. Okay, so what if you want to simply delete something from, or delete a specific thing from a list? We can use what is known as l.remove, and that's going to allow us to remove something. So let's say I want to remove 1. I can print off L, and what this is going to do is it's going to remove the first occurrence of that item. So I can say remove Alice. And she's gone from the list. But if I have Alice in here twice, she's going to remain in the list, because remove only gets rid of the first occurrence of something. There's a couple different ways that you can kind of get rid of all occurrences of a person in a list. You can go through a for loop, etc. We're going to get to that in a later video. For right now, just get comfortable with the remove. Allows for you to remove the first occurrence of a person in a list. So that's going to be how you remove something. How do you insert something? Well, we can do l.insert, and insert is going to take 2 arguments. The first thing is going to be where you want to insert. So let's insert there, and we're going to say Bob. And I'm going to put Bob in position 0. So it's going to be right in here. So we print that off. We see that Bob is now in position 0. And we can do 2 and kind of move all the way up that list and just kind of drop them in wherever we want to. I don't use insert a whole bunch. In my Python scripts for DH, I'm not really sure why. I just don't really need it that often, but it's something to think about. So another thing that we can do is we can do to sort everything. We can say L dot sort. We can print off L, and you're going to see that you're going to get a type error. And the reason why you're getting a type error is because you have Alice and Allison here. So it doesn't know how to sort those. If we print off sort like that, you're going to see nothing happens. But if we do it like this, we're going to see that it's going to automatically sort down into the lowest numerical. So it's going to drop 1 down to with 1. If you're dealing with a list of names, let's add Bob, Cindy, and we're going to add Anna. You print that off. Now that you're dealing with all strings in your list, it's going to print them off and sort them alphabetically. So Anna gets bumped to the front of the list. So that's going to be how you kind of handle that problem. Now here's a fun one. I wasn't going to talk about this in this video, but we're going to talk about it anyway. We're going to talk about something called a set. A set is a list that does not contain any duplicates. So let's say, for whatever reason, we're going to sort this out. So we're going to print it off. Now we have Anna twice. And we don't want to have Anna twice, but we don't want to have to manually go through the list and check. So how can we kind of make all of this into a list with no duplicates? Let's add a couple extra duplicates. We're going to have an extra Bob too. So we print this off. We've got 2 Bobs and 2 Annas. Well, we can say that we can make a new one. We can say S is equal to set. And what we're going to do is we're going to force L to become a new data structure called a set. And when we print off L, we see, oh, there we go, print off S. We see that what we have now is squiggly brackets. And we see that Bob, Anna, and Cindy, and it's all kind of been removed. We've got really a new data structure here. We have a set, and we can delineate a set. Let's make S1 with squiggly brackets. But unlike a dictionary where we have a key, colon, value, in a set, we're just going to have the same thing as a list. So we're going to have 1, 2, 3, 4, 5. Let's say 5. Print S1. And we're going to have that extra 5 get removed because a set cannot have duplicates. Believe it or not, you are going to use this a whole bunch. You are oftentimes going to have to remove duplicates from a list, and the easiest way to do that is to convert it into a set. And once you do, you can very easily go back and then reconvert L back into L is going to equal list S. And what that's going to do is allow us to print off L again, and it's going to go through memory, sort it, and then it's going to convert it into a set, and then it's going to reconvert it back into a list by using this list operator, this list function, sorry. And so that's how we're going to be able to reconstitute that list, or the set back into a list. Hopefully that makes sense. So again, set is just another data structure. Now you're oftentimes not going to create the set by starting off. You're going to create a list and then realize you've got lots of duplicates and you want to get rid of them. This is the easiest and quickest way to do it. If you look at Python tutorials online, you'll see other ways to do it. You can go through the list manually in a for loop and see if there's another occurrence of it and then delete it if there is. And that's not necessary. The only time that is going to be necessary is if you're looking for items in a list that are similar. So they have a similar first name and you want to delete all those duplicates. Set won't get that. Again, we're not going to deal with that here. We're going to deal with that when we talk about for loops in lecture number 9. So that's all going to be all for right now. Thank you for listening, and if you've enjoyed this video, please do like and subscribe down below, and visit us over here at pythonhumanities.com. If we go to Python Humanities and we go to the 4DH course, and we look at Lesson 6 under Part 2, you'll get to this page here, which is the Python lists. It's some of the text that we kind of talked about, and it'll go through and give you some instructional kind of coding exercises and things like that to kind of interact with Python on the website, and you can kind of go through and test your knowledge follow these instructions 1 through 7, and if you get stuck, go to the cheat sheet and it'll tell you a couple tips on how to solve those problems. So that's going to be it for this video though. Thank you for listening.
Thank you for watching this video. If you've enjoyed it, please like and subscribe down below and visit us at pythonhumanities.com.